Hello viewers and my dear students, welcome to session 12 on projection of plane surfaces demo. We have started with circular lamina, and in this circular lamina itself 3 sessions have already been completed. This is the 4th session what we are doing, and I think in this session we will be completing this circular lamina projection demo. Now you see here, till this we have done already. Okay, now in the last session we had completed till this, we had got the points carefully done and all that. Now what you do, the best thing is always this session means always keep enlarging, keep zooming, keep zooming in that way. You do this and you just check whether the points are okay. Now see here on this E is okay. On this D is okay. Okay, this is E, this is E is okay. On this D and F, D from here and F from here okay, and C from here, and again G from here, G is here, G from here okay, okay. Then on this B and H, B and H is the extreme thing, that is also okay, and it is A, and it is lying on a point of its rim or circumference A on HP. In that way, I have all the points marked. These points I have named the corners using text command. Now you have to join this by a curve. The best thing what I suggest is you do arc by 3 points. Okay, arc by 3 points. Now what you suggest is, again you enlarge this is better. Again enlarge the area. Okay, now we'll have these 3 points taken first. First, that is 3 points means first you take this point, and this point you take. You are getting this one part of the curve. These 3 you'll draw. These 3 also you'll draw. One point is this, and this is the one. Then passing through this point. Okay, this is the thing, and again taking this, and again ending point is this, and point on the curve is this. Carefully follow. Okay, and again first point is this, second point is this, say end point of the arc, and point on the curve is this. In that way you have finished. Okay, this is how it is seen, and if you zoom it, it will be little better. Okay, now as you see here, the circular lamina of diameter 125, that is 62.5, has a point of its rim or circumference on HP. That means point A on HP, such that the surface is inclined at 60 degrees to HP, or diameter inclined at 60 degrees to HP. The diameter is AE. Can you follow? AE is because it is in true length here. Since we move parallel to VP, attached to VP itself, parallel to VP means when you move it parallel to VP, okay, when you move this parallel to VP, the true length should be still be seen in its true length. That's why AE, okay, is the diameter which is inclined at 60 degrees to HP. That means when you have A as the fixed point, E if you move it, this AE will be parallel to VP, because as you see here, AE if it is parallel to XY, it is parallel to VP, true length is seen in the front view. In that way, as long as inclination is kept constant, the top view should remain same. Okay, these things I have told you so many number of times. Now what I have done is, with inclination at 60 degrees to HP, when you look from the top, okay, when you look from here, this is how it appears. It appears as an ellipse. What they have said is, the top view of the diameter containing the point on HP. That means point on HP is A. The diameter containing the point on HP is AE. Did you follow? The diameter containing the point on HP is AE. That is inclined at 45 degrees to VP they are given. You incline this at 45 degrees to VP. That means what you do is, already I have told you, first you just move, copy and paste here. Then you incline it at 45 degrees to VP. Okay. And I have already shown in the last session, okay, take the projectors up and carefully get the points correctly on this E, on this D and F, on this C and G, on this B and H, on this A. In that way, once you get that, getting three points, these 3 points, that is these 3 points I got, these 3 points I got, and then these 3 points, these 3 points. In that way, 3-point arc I have done it to complete the ellipse. Now this problem is what here point A is on HP, A dash is on X1, correct? No, point A is on HP. Surface inclined at 60 degrees to HP. Keeping 60 degrees to HP constant, pivoting at A, I have rotated this. I have rotated this, keeping inclination to HP constant. I have rotated this such that the top view of the diameter containing the point A is inclined at 45 degrees to VP. Okay, once you do this, this top view and this top view remain same, because for this top view is inclination to HP is same. Okay. Now once you have got this top view and this top view same, but the only thing is the top view of the diameter contains the point A and HP. Okay, that is AE inclined at 45 degrees. Get all the points and are drawn by 3-point arc, and this is the completion. Okay. Now this is the problem what we wanted. This naturally takes more time. You have to be very careful, and more than anything else, it will be very helpful for your career, because to this concentration you should do, and at any cost you should be in a position to complete such problems. I've seen very few people doing completely in the exam. Okay, halfway through they come, they get confused and stop. Now I've clearly shown in 4 sessions. Please understand, in 4 sessions I've done this, and I've made this as simple as possible. Carefully you do. Okay. Now this is the thing. Now you see here, in case now point on HP, surface or diameter inclined at 60 degrees to HP. Now what I have given is top view of the diameter contain the point on HP is inclined at 45 degrees to VP, means you do this. If I say other diameter perpendicular to the previous means CG. Can you understand? Other diameter perpendicular to the previous is CG. This is already in true length. Can you see? This 62.5 means this is also 62.5. This, since it is parallel to HP, true length can be seen in the top view. If I say other diameter, not the same diameter, diameter containing the point on HP. If they say other diameter is inclined at 45 degrees to VP, means carefully you do. Other diameter perpendicular to the previous means you have to take CG only. Okay. This is already in true length. You don't have to worry about anything. You incline CG at 45 degrees to VP. Okay. If they say other diameter perpendicular to the point, that is, this is the other diameter. That means one diameter is AE. AE is what? This is point A and HP. This diameter is what? The diameter containing the point on HP. Okay. This AE is the diameter containing the point on HP. Other diameter is this. If they say other diameter is inclined at 50 degrees to VP, means make CG inclined at 50 degrees to VP and get the front view in the same way. If they say other diameter perpendicular to the previous, that means again CG parallel to both HP VP means, okay, it is already parallel to HP. Make CG parallel to XY line also, so that it is parallel to both HP and VP also. Did you follow? Same way, they can give anything. Here if I say, now the problem is point A is on HP, correct? No? But that is point A is on HP. If they say the point on HP is also lying on VP, means in the third stage top view, see that A is on XY line. This copy and paste such that A is on XY line and AE perpendicular to XY line. Okay. In the same way, point on HP and the opposite point on the same diameter is touching VP means see that E touches XY line. Okay. And with all this, these things I've done it in the different sessions under 19A, B, C, D and all that. You please go through. Now I'm anyway repeating since we have taken solid edge procedure to do. I'm again repeating. It's a sort of revision exercise for you. See here, this imagine RPP here. RPP here. If they say diameter containing the point on HP, okay, that means AE no. If they say diameter containing the point on HP is parallel to profile plane means make AE perpendicular to XY line. Make AE perpendicular to XY line so that it is parallel to X1 Y1 line here. Is it okay? In that way, any complex problem given here can be done. Okay. See here always if they say other diameter perpendicular to the previous means you have to take CG only. If they say other diameter perpendicular to the previous is inclined at 60 degrees to VP means make CG inclined at 60 degrees to VP. Either this way or this way. If they say other diameter perpendicular to the previous is parallel to both HV VP means make CG is already parallel to HP perpendicular to VP. Now make CG parallel to XY line. Okay. Did you follow? In the same way, if they say point on HP is also on VP means put A on XY line so that AE is perpendicular to XY line. If they say point on HP, opposite point on the same diameter touching VP means you copy, paste and move in such a way that AE should be perpendicular, E should be on XY line. In that way, any complex things given can easily be managed. And importantly, please understand, if they say the diameter containing the point on HP, that is AE, diameter containing the point on HP, that is AE, is parallel to profile plane means make AE perpendicular to XY line. Okay. If E is nearer, lamina is leaning towards the observer. If A is nearer, lamina is leaning away from the observer. Anything what you do. If they don't say anything, you can do anything. Okay. AE, if you make it perpendicular to XY line, then for an imaginary X1 Y1 line here and RPP and all that here, it is parallel to the profile plane. Okay. If they say point on HP, diameter inclined at 60 degrees to HP and parallel to profile plane means immediately make AE perpendicular to XY line. In the third stage top view, get the corresponding front view. In that way, we have finished the problem number, that is problem number 19 extra 4, the circular lamina. We have taken 4 sessions to complete. Thank you very much for watching. We'll continue in the next session. Thank you.